Hey everyone, and welcome to our video of using SOHCAHTOA with inverse trig. So we're going to start this by looking at a triangle, and then we're going to find an angle with a calculator. But one of the ways that we do this is this rule right here. So if we have a trig inverse function equal to an angle, that means the regular trig function of that angle should be equal to that x value. So we're just using random letters, so that x can be w, z, so that letter doesn't matter. But what it's just saying is that we can rewrite these back and forth. So we'll see that in this problem. So in this problem, it says find the angle as an exact value in terms of an inverse trig function and as an approximation in degrees to two decimal places if a equals 8, so let's just put that in, there's 8, and b equals 13. Okay, and we're trying to find this angle. I'm just going to mark it. We see theta there. And well, it's a right triangle, so we can label it. We've got opposite, that's adjacent. C would be hypotenuse if they gave us that, but we don't, it looks like we don't even need it because we can just jump to SOHCAHTOA and say, well, I have opposite and adjacent. I should do the TOA part. So we would have tangent of that theta is equal to opposite 13 over adjacent 8. Okay, and then now we're going to use this rule up here. So we're using the rule from this way to this way. Okay, so notice we want the angle will be by itself. So using our inverse rule, we would have tangent inverse of the 13/8 equal to that angle. Okay, so that's that rule being used. And then this is the exact value answer. So this is the exact value because that is theta by itself. It might be good to put the 13/8 in parentheses. And I'm going to label it down below. That is the exact value. Okay, but it also says use a calculator or approximate to two decimal places. Okay, so to do that, well, the calculator has this in it. Let me rewrite theta on the left. And we just type it in exactly as we see it here. I'm going to use approximately though. Okay, so I've got Desmos already ready. Here it is. And then it's in the functions. And then here's tangent inverse. And then you can just type in 13 divided by 8. There we go. It's in degrees already. So if it wanted it in radians, we could change it. So there's the radian decimal answer. Here's the degree answer. So what we want is 58.39 degrees. Okay, because it said degrees in two decimal places. And there we are. Okay, so this is called an approximation. So when they ask for an exact value, that's the first answer. So it's basically what we would be getting to before we plug anything into a calculator. Whereas an approximation is when we plug something into a calculator. Okay, so that's it. With these problems, we want to kind of make sure it makes a little bit of sense there. Yeah, I think that 58.39 degrees makes sense. Here's 58.39. Because it's a right triangle, we could find this other angle right away. Okay, so finding that other angle, let's say, I'm just going to say it's about 32. And notice the 32 degrees matches with the smaller side, medium angle, medium side. 90-degree matches with the hypotenuse, which should be the largest side. Okay, so that's what I mean. You could kind of check it real quick, making sure at least the properties of the triangle are matching. Okay, but that's it. Okay, so if you have questions, please let me know. Otherwise, thanks for watching. See you again soon.